Now this is our original f of x that we used in the previous video, but this time what I want to do is, let's say I want to add 1, okay, add 1, but inside the bracket this time, not on the outside. Remember previously I applied this kind of transformation, adding or taking away outside the bracket. Here it's inside the bracket. I want to see what happens, right? Well, what does that look like? Okay, what's that? How's that going to change? Whenever you see x's here, you're adding 1. Whenever you see x, add 1. Square plus 2. See that x there? You do x plus 1, and that's minus 1. That's what it is. I want to see what that looks like now. If you look at the graph, what I've just highlighted there, that's my original f of x. I'm going to copy that. So when I see x, I'm going to add 1. There. So this one that I've highlighted now is over here, x plus 1 inside the bracket. So what's happened now? You can see the red one there, that's the original one. Now I've applied the transformation plus 1 inside the bracket. It looks like the graph has shifted not 1 to the right, it's actually shifted to the left, 1 place or 1 square to the left. Right. Let's see what happens now. Let's try this same one, f of x, and this time I'll do x plus 3. What do you think might happen now? Right, I'm going to plus 3 wherever I see x, plus 3. There you go. What's happened now? If you look at the original one there, look, if you just look at the graph there, the minimum point, if you look at the minimum point of the red graph, the original f of x, it's gone 1, 2, 3 places to the left. So by adding 3 inside the bracket, it's moved, the original graph, f of x, has moved 3 places to the left. Now what about if I want to try this? What do you think might happen if I did this? Minus 2. It's not going to go down, it doesn't go up. We've established that whatever you do inside the bracket does not make the graph go up or down, right? That does not happen. Minus 2. What you can see now is the original one is right here. I'm tracing the original one here. That's the minimum point. It looks like when you do minus 2 inside the bracket, it goes 1, 2 squares to the right. So that's a transformation of 2 squares to the right. Let's say we've got some random graph. I'll make up some random graph over here. Okay, just ignore that for now. Let's say we've got f of x and it represents this graph over here. And the minimum, sorry, that point there, the minimum point, 5 along the corridor, -1 down the stairs. I want to know what happens to that point when I apply this transformation. Remember, it's inside the bracket. So it's going to either shift left or right, not up or down, left or right, because it's inside the bracket. Being -1 inside the bracket, it's not going to shift 1 to the left, as we've seen with the examples that I've just shown. It's actually going to move 1 place to the right. So that graph there goes somewhere over here. right there. So that minimum point there comes right here. So what will that be now? Remember, that one there, it's -1 down the stairs. That one's still -1 down the stairs. It's not gone any further down. So that one there is still -1 down the stairs. But that there, that 5, remember that's 5 along the corridor. It's gone 1 extra to the right. So it'll be 5 plus the 1, that will be 6. So that's the new coordinate. So the effect of this transformation on this coordinate is that it moves 1 place to the right. That's the new coordinate. Right, what about if I did this? Right, it's inside the bracket. It's going to move 3 places to the left. It's going to go that way. So that point there, it's going to go 1, 2, 3 places. 3 places, 1, 2, 3, right there somewhere. 1, 2, 3. So it'll be 5 take away 3 is 2, and that second number there, the second coordinate, the y coordinate, will not change. So the effect of that on this coordinate will be that it moves 3 places to the left.